Let's look at another example. Suppose that point P is on a circle with radius of 20 centimeters, and ray OP is rotating with an angular speed of pi 18 radians per second. They would need us to find three different things. The first one is to find the angle generated by point P in 6 seconds. We already know that we are given the angular speed, which is pi over 18 radians per second. We know the formula for angular speed, which is omega equals theta over t. Therefore, within this problem, I know that I'm given 6 seconds, and I know omega, therefore I can solve for theta. Let's just substitute in. For my omega, I'm going to get pi over 18, and this will be radians per second. That's given to us in the problem. We're trying to find theta, and I'm given the amount of time that they want us to associate that with, which is 6 seconds. Now I just multiply both sides by 6 seconds to solve for theta. And when I cancel out, the seconds will cancel out, and I simplify the values. I'm going to get theta equal to pi over 3, and what's left is going to be radians. Part B of the example wants us to find the distance traveled by P along the circle in 6 seconds. Distance means that I want to solve for arc length, which is S equals R theta. Here, S is the arc length, R is the radius of the circle, and theta is in terms of radians, which I found in part A. All I need to do is substitute the values in and determine the arc length. Here, the radius is given to be 20 centimeters. Times theta, which I know is pi over 3. So when I simplify, I know that my arc length is going to be 20 pi over 3 centimeters. For part C, they want us to find the linear speed of P. Well, we know from our previous page that velocity is equal to S over t. We already determined what S is from the previous part B, which is going to be 20 pi over 3 centimeters. And I know that t is given to be 6 seconds. So all I did is substitute into my known formula, and then I'm going to simplify, which is going to give me 20 pi over 3 times 1 over 6, because this is divided by 6, and when I take the reciprocal, it's going to be 1 over 6, and therefore I simplify, and I'm going to get a solution for velocity to be 10 pi over 9, and that would be centimeters per second. Another way of doing this is to use the previous formula, which is going to be velocity equals r times omega, which would be, in this circumstance, 20 times pi over 18, and then that would simplify down to the same solution. So either formula would work. Another example, we have a belt that runs a pulley of radius of 6 centimeters at 80 revolutions per minute. They want us to find the angular speed of the pulley in radians per second. We always want to find theta first. And remember from previous slides that if we're given revolutions, we can find theta. So theta is going to equal 1 revolution, which is 2 pi, and in this situation we have 80 revolutions. So we're going to multiply 2 pi times 80. That gives me 160 pi radians. Now, I can use our formula for omega, which will equal W over theta over t, and then just substitute in. Here, theta was found to be 160 pi radians, and t is going to be given to us per minute, which is going to give us 60 seconds because they want our solution to be in seconds. Then I'm just going to simplify the problem. The zeros are going to cancel. 2 is going to go in the both. That's going to be 8 pi over 3 radians per second. Continuing with the previous problem, they now want us to find the linear speed of the belt in centimeters per second. Remember, the linear speed of the belt will be the same as that of a point on the circumference of that pulley. So again, what we want to do here is find the velocity. Remember, the velocity or linear speed is going to equal s over t. This is from the diagram on previous slides. We also know that s is going to be r theta. And now all we need to do is substitute our known information into this formula and calculate our linear speed. So here, our linear speed is equal to the radius, and our radius in this problem is going to be 6 centimeters, that was on our previous slide, times our theta over t, or our omega, which is going to be 8 pi over 3 radians per second. And then I just simplify this expression. And when I do, I'm going to get 16 pi centimeters per second. If I substitute this into a calculator, I can get a decimal value, which would be 50.3 centimeters per second. I put both solutions down so you can see how solutions can differ if you check your solutions in the back of the book. In another example, we have a satellite traveling in a circular orbit 1,600 kilometers above the Earth, and it takes 2 hours to make one orbit, or one revolution. The radius of the Earth is about 6,400 kilometers. We have a two-part question, and the first part asks us to find the linear speed of the satellite. But recall, we always need to find theta first. So in our problem, this satellite's going to make one orbit. That is one revolution. Therefore, theta is going to be 2 pi radians. Then we need to find omega. Omega is going to equal theta over t. We already have theta, which is 2 pi radians, and we know that t is going to take us 2 hours for that one revolution, or that one orbit. When I substitute and simplify, this is going to give us omega, which is going to be pi radians per hour. Part B is going to ask us to find the distance the satellite travels in 4.5 hours. The first thing we need to do here is to find the velocity. But remember, the velocity is going to equal r theta over t. We're given the radius to be 6,400 kilometers. And we determined theta over t on part A, which is going to be pi radians per hour. When we simplify, we're going to get a velocity that is equal to 6,400 pi kilometers per hour. To complete this problem, we need to recall from algebra that we have distance equaling rate times time. Here, our rate is the velocity that we just determined. So all we need to do is substitute in our values for velocity, or r, and our time t, which in part B, they want us to have 4.5 hours. So our rate or velocity we already determined to be 6,400 pi kilometers per hour times our hours, which is 4.5 hours. Then, when I simplify, I'm going to get 28,800 pi kilometers. Now, if I substitute this into a calculator, I'll get 90,477.9 kilometers.